Right now, I believe that, if you are having good enough understanding of data science, then basically you can go into the details of these functions and how this will look like. So these are our input images. Okay, so these are images, some transformation we have applied, but these are still the real person's images. Okay, we are just defining the losses. So as I said, our goal is to reduce the losses as much as possible. So here we are just creating the functions for losses, which will just basically later. Right now, I believe that, if you are having good enough understanding of data science, then basically you can go into the details of these functions. Otherwise, for implementation of this entire process, don't go into much details of these things. Okay, these, slowly you will grasp all these things, but right now you can just run. Once this image extraction part is done, okay, you don't have to go into much details of this. So first of all, in this particular step, we are just importing the necessary libraries of Python. Okay, what will be? So basically, we had just mentioned the word PyTorch, right? So the short name, or maybe I can say in Python, that has been referred to as Torch. Okay, so PyTorch is referred as Torch. So there is one related library, Torch Vision as well. Okay, which is used for transforming the data and all. So you just have to run this line as it is. Okay, it basically import all the necessary libraries, okay, which are required to implement the entire project. Okay, then what we are doing, we are just testing whether we are fine for this project or not. So there are a couple of checks which we are doing, basically basic checks. Those are basically here written as test assert test, and then test discriminator and test generator. So these are just functions. Again, as I said, don't go into much details of these things. Okay, you just have to run this. After that, there is a data loader function. So this data loader will ensure that we are able to get the data into this environment. Okay, so this function is used for basically getting the data into this environment of Jupyter Notebook. Okay, after that, what we are doing, since those images are quite, basically if you just download the images and open, you will see that those images are basically high memory computation. Okay, basically those are high size of high size. So what we'll do is we'll just apply some transformation so that our training process will be smoothened out. Okay, so if you just run this cell, and then after that there is a function called as im show. Okay, so with the help of im show, we'll be seeing what kind of images we are having, and after transformation how this will look like. So these are our input images. Okay, so these are images, some transformation we have applied, but these are still the real person's images. Okay, still we haven't trained any models and anything. Okay, after this, what we'll do, first of all, we'll just scale these images. Okay, right now these are the images. First of all, we'll just scale these images. Okay, and after that, if you see, after images, after the scaling, okay, we are just seeing what, how the sizes will look like. So basically this is a size of the tensor. You might not be understanding this right now, but maybe over the time you will understand. Here this is smart important step. It says that define the model. So here we are defining our deep learning model. Okay, here it says that define conv. So basically there is a class of deep learning network called as convolution neural network. Okay, which we will be generally using for image data set. Okay, so here we are defining that network. Okay, again, as I said, once you start learning the deep learning and all things, then you will be able to understand how this convolution layer is created, how this entire network is implemented. But for now, we can just run this. Okay, after this, we are basically creating a class of discriminator. So as I said, there are two networks, right? One is discriminator and one is basically generator. So here we are just defining the discriminator layer. Okay, and after that, okay, we are just implementing test discriminator. Okay, so test discriminator will ensure that our basically process of discrimination creation is fine. Then same step has been performed for generator as well. Okay, so here we are just performing the basically create a generator function. Okay, so after this, both our generator and discriminator are created. Then we are just initializing. So I think Gaurav has asked like how it is initialized. So this is how we will be just initializing. Okay, those matrix values. So this wait init normal function is for initialization of those values. Okay, And then here we are just finally we are just combining those two networks, discriminator and generator. Okay, so as I said, there are two networks, discriminator and generator. So here we are just combining those two networks. Okay, and now we are just defining the model hyperparameters. So there are different hyperparameters which just ensures that our model training goes smooth, and depending on the hyperparameter, our performance of the model also is dependent. So basically, the better are the hyperparameters, the better will be the performance of the model. Okay, so here we are just defining those hyperparameters. Now if you see, okay, what we are doing here, we are just ensuring that we are training on the GPUs. Okay, so here we are just ensuring that our training is done on GPU, and if it is not available, then we'll not be using, okay, GPU. Now we are here, we are just defining the losses. So as I said, our goal is to reduce the losses as much as possible. So here we are just creating the functions for losses, which will just basically measure how much is the loss present in our model training. Okay, and then we are having optimizers. So there was one liner about optimizers as well. So if you see this term Adam, so Adam basically is an optimizer which is quite useful in deep learning part, which just ensures that our error should be minimized, okay, as much as possible. So this was all layered definition, and then all the neural network definition. Now we'll be starting the training. Okay, so this is the training part. Okay, here we have basically implemented the logic how the entire thing will be trained. Okay, and as I said, there is concept of epochs. Okay, so in the later, just after this, we will see the epochs concept. So here if you see, it says that n epochs, n underscore epochs. So what happens is, if you are if you are sure that we are having larger compute capacities, okay, and larger data set, you can just increase the epoch. So what happens is, if you just increase the epoch, larger time will be required for training the network. Okay? Right now I have just kept it as 20. It's up to you, you can mention 100 as well. But what will happen is, if you just let's say for 20, our model training took, let's say for example, 10 minutes. So for 100 it might take around 50 to 55 minutes. Okay, but that our model improves. Okay, so here I have just defined box. What done, operations will be performed to understand the patterns in the data or patterns in the image. Okay, so that's what we are basically under with any epochs. So if I just execute this particular cell, okay, see a couple of messages which are printed. Okay, after once this entire thing start. Okay, so now you can see this epoch 1/20. Okay, so 1/20 is running, like 20 epochs are there, and first epoch is running right now. And for all of these steps, you are seeing D underscore loss, G underscore loss. These are the values of discriminator loss and generator loss. Okay, so inside this each of these 20 epochs, we are passing some images on which we are getting in this discriminator loss and generator loss. So what I'll do is, this training will take some time, so I will not take much of your time. I will just show you how exactly it will look like after generation. Okay, just a second. So I have already trained that on my system, okay, previously. Okay, so as I said, right now I'm just using 20 epochs. If you just increase the epoch, basically the model performance will be better. So right now, if you see, this is in the first epoch. After first epoch, if you see, the images are not looking quite good, right? But the fact is that you might be seeing that the same image is being basically shown in different way. Like if you see this particular image and this particular image, these both images, okay, the rightmost upper image, the both of images are same, but still they are looking quite different. So this is the concept of GAN, that similar data, same data will be used, but every time after every epoch a new kind of data will be generated. And again, if you take a look at this, the bottom right corner image as well. Okay, after every epoch the form is changing. If you see here, no beard and nothing was there, but after that, if you can just observe, some beard is also visible, right? Here, if you see this image, it is looking like someone who is basically residing in foreign countries. But here, if you see, the image is transformed in such a way that it looks like an Indian person image. So this is how GANs uses that model. Okay, GANs use mission, which basically will ensure